guys, ito na yung ating huling example under material balances for single unit non-reactive processes. So our last example is crystallization. So crystallization is an important separation technique, okay, kung saan it involves solidifying a dissolved substance from a solution so it can be easily separated. So meron kang solution, you want to recover the solute dissolved in the solution. How? You solidify them. But how do you exactly solidify them? You can do that either by lowering the temperature or by removing some solvent. So when you remove some solvent, of course, magkakaroon ng pagbabago sa solubility. So the solute will be less soluble to that amount of solvent na na-reduce. Okay? Or if you lower the temperature naman, ganoon din ang effect. If you lower the temperature, the solubility will change, it will become less soluble, and you will expect na yung dissolved substance magsusolidify, magka-crystallize doon sa iyong solution. Okay? Or you can do both of these processes at the same time. Okay? Now, ito yung ating basic crystallizer unit diagram. So this is your solution. Okay? So if you lower the temperature, okay, cooling, or remove some solvent, so kaya nga may water dito na stream, and removing of solvent could be achieved, pwedeng evaporation yan. Okay? Or again, if you lower the temperature or remove some solvent, so ang mangyayari, okay, magkakaroon ng pagbabago sa solubility. So yung kaninang nakadissolve dyan, so let's say this is your solution. Okay? Solution ka. You do these two, either of these two. So we'll expect na yung solute, okay, kaya ganyan yung ating shape din ng crystallizer para yung ating solids or solute easily recovered sila. So ganyan ang mangyayari, no? Magkakaroon ng paghihiwalay, separation ng solute from the solvent. Okay? So this liquid here, okay, yung natitirang liquid, this one, yun tinatawag nating mother liquor. Okay? Of course, you will expect na in most cases, yung mother liquor, meron pa rin konting nakadissolve sa kanya. Alright? Now, itong mare-recover mo dito, yun yung tinatawag nating crop or crystals. So, ang tawag talaga dyan ay crop. However, sometimes, no, yung crop, basa yan. So, if you have your wet crop, okay, so let's say this is a wet crop, you have to take into account yung solubility nung solution na nag-wet dun sa crystals natin. Okay, so you have to take that into account in our material balances. Now, if you only take into account yung lamang solids or solutes na nare-recover natin, ang tawag dyan ay crystals. Okay? So, saan ba ginagamit itong crystallization? So, again, if you want to recover a certain product, okay, so you can do this unit operation. In bioprocessing, we normally do this to purify ang iba't ibang products of biological nature. Kasama na dyan yung proteins, right? We need to purify your proteins so that we can study more of it, maybe even elucidate, deduce its structure. Okay, not just proteins, also pwede yung mga pharmaceuticals like antibiotics. So most of these antibiotics actually, isa ang crystallization sa mga huling downstream processes na kinakailangan gawin to recover pure products of these industries. Okay? Ano pa? Some peptides also can be recovered using crystallization. Even yung salts of your amino acids, salts of glutamic acid, for example. An example is monosodium glutamic acid or monosodium glutamate rather. Okay, so that is basically solid. So you have to recover the pure form of that, and crystallization is used to achieve just that. Okay. So I have here an example, and let me read this to you. A salt solution weighing 10,000 kilograms with 30% sodium carbonate is cooled to 293 Kelvin. The salt crystallizes as the decahydrate. Okay. What will be the yield of Na2CO3H2O crystals? Actually, this should be 10H2O kasi decahydrate daw siya. So please correct that. Okay. Sodium carbonate decahydrate crystals. If the solubility is 21.5 kilogram anhydrous Na2CO3 per 100 kilogram total water. So given ka ng solubility. And you should perform this calculation for the following cases. Number one, first you have to assume that no water is evaporated. Okay, so naalala nyo kanina yung water removed. So assume nyo muna for letter A na wala yon. And letter B, assume that 3% of the total weight of the solution is lost by evaporation of water in cooling. So I will give you time to maybe pause this slide or this video and try to read one more time itong problem para mas maintindihan natin siya. If you did that, so now let's try to solve this problem. Okay, so let me just open a blank worksheet here. Okay, so it's not really blank, but okay, let's use this one. And first, let's try to draw yung ating flow sheet. So we have what? Oops, it's in blue, so let me use black. Ayan, so let's have this rectangle or block. At ito yung ating single unit. Pero sabihin natin ito na yung ating cooler plus crystallizer. Okay? Because yun nga, usually crystallization involves lowering the temperature. Okay, so this is your feed. Okay. And let's use the symbol W for the water remove. Let's use C for the crop or crystals. And here is your mother liquor. Now, ano yung F natin? Ano yung feed? So sabi sa problem, okay, ano ba sabi sa problem? We have 10,000 kilograms. Okay. So 10,000 kilogram of your solution. Okay. And what is the identity? What is the solute in that solution? So sabi dyan, meron ka daw 30% na salt or Na2CO3. Okay? Ano pa? Yung ating mother liquor. So do we have anything given about the mother liquor? So wala, no? But what we know, okay, kasi yung mother liquor natin, saturated yan. Okay? So we know the solubility. So the solubility here in the mother liquor, sabi sa problem, 21.5 kilogram anhydrous Na2CO3. Okay? Ibig sabihin yung hindi hydrous or yung walang water per 100 kilogram of water. Okay? So yun yung mother liquor natin. Diyan natin sinulat yung solubility kasi mother liquor is essentially a soluble, a saturated solution. Okay? Now in the crop, okay, ano ba yung identity nung sodium carbonate crystals na na-form natin? So sabi sa problem, Na2CO3, okay, decahydrate. Tama ba? So that's decahydrate. Okay. So what should be a good basis for our calculation? Well, given naman kasi yung ating amount ni feed. So we can use that as our basis, 10,000 kilogram of feed. Okay. Now let's try to write the overall material balance. But before that, dito sa ating calculation, importante na malaman natin ang molecular weights, okay, ng ating solute and ng product natin. So molecular weights. Okay, for Na2CO3, ang molecular weight niya, later on I will show you kung bakit kailangan ng molecular weight. So si Na2CO3, the molecular weight is 106. Okay? Now, for water, it's 18, right? So for a decahydrate, okay, 10 times water, 10 times the molecular weight of water, so that should be 180.2 kasi 18.02 yung kay water. And therefore, if you want to solve for the whole decahydrate, okay, so salt decahydrate, yung kanyang molecular weight daw, if you're going to compute this, it will give you 286.2. Okay, so this molecular weights later, importante yan. Now, let's proceed to the overall material balance. Okay, so basically F equals what? Yung ating W, maybe I'll write first yung mother liquor na lang. So mother liquor plus yung crop plus yung W. Okay? So yan yung ating overall material balance. Now, next is component balance. Okay? So anong component na pwede natin gawa ng balance? So pwedeng yung salt, pwedeng water, okay? Pwede rin kaya ang decahydrate. So let's see. But I would use for now yung salt. Okay. Na2CO3 balance. So if you do this, okay, that would be salt in F equals salt in ml plus salt in the crop plus salt in the removed water. Okay. So, ilan ba ang Na2CO3 doon sa ating feed? So, yun, no? 30%. So, that's 0.30. Tama ba? Times 10,000. Okay? Equals salt sa mother liquor. Meron ka bang Na2CO3 sa mother liquor? Yes, meron, di ba? Although nahiwalay na yung crop kay mother liquor, you will expect na meron pa rin nakadissolve kahit paanong Na2CO3 dun sa saturated mo nga na mother liquor solution. Ang tanong is how much or what is the percent nung Na2CO3 kay mother liquor? So wala kang given na percent, right? But you can actually solve that kasi meron ka namang given na solubility. Okay, so paano yan? So, if let's say you have a basis of, okay, I will make a separate basis here of, just for this case, okay, 100 kilogram water. So this basis is not for the whole operation, but just for this expression. No? Kapag 100 kilogram ang water mo, okay, ano ngayon yung percent or yung fraction ni Na2CO3? Okay, so percent, in fact, I'll use probably a different color this time, probably blue. So yung percent Na2CO3 in the mother liquor is what? E di yung 21.5, right? Divided by the amount of your solution. Eh, ilan ba yung amount of solution mo? Pinagsama mo yung solute, which is 21.5 plus yung solvent na 100. Tama ba? 4 times 100%. So, you will be able to get what? 21.5 divided by 21.5 plus 100. And you will get 17.7%. So yan yung gagamitin natin ngayon dito sa salt balance natin or Na2CO3 balance. So that's 0.177, okay, of ml. Okay, plus crop naman tayo. Dito tayo sa crop. Ilan yung Na2CO3 sa crop? Malalaman ba natin yan? Well, we don't know. We don't have the value, but fortunately, we know the identity of the crystal, which is sodium carbonate decahydrate, right? Kaya kung ang pinaghahanap itong mga molecular weights, okay? So, if this is the whole crystal, the percentage of that in the whole crystal, so the percentage of Na2CO3 in the whole crystal will be the percent Na2CO3 in your C. Tama ba? So, we can go ahead and use yung ating molecular weights. So, here I will create a side calculation. So, percent, okay, Na2CO3 in crop, okay, equals. So we can use the molecular weight. Ano bang molecular weight nung Na2CO3, di ba? 106. Divided by 106 plus, divided by the whole molecular weight of the decahydrate, which is 286.2. So I was supposed to put here 106 plus 180.2, pero meron na pala tayo ng sum. So I hope you got that one, no? We want to determine the percentage of Na2CO3 in the crop. How do we do that? We use the molecular weights, okay? 106.0 kasi yan yung molecular weight ni Na2CO3, then 286.2 kasi yun yung sa buong crystals, okay? Again, this is assuming na walang adhering solution, hindi wet yung ating crystal. So times 100 ika nga para maging percent siya, just to show the percentage. And doing that will give you 37%. Okay, so let's go ahead and use that 37% here. So naka-crop na tayo, di ba? So that's 0.37 C. Okay. Plus kay W naman. Okay. So if we are going to answer letter A in the problem, sabi sa letter A, let's assume na no water evaporated. So no water, okay, evaporated. So if that's the case, kung walang tubig na na-evaporate, di zero na to. Okay? So you have now your equation 1. Now, where do you get the second equation to solve the two unknowns? Well, we can perform water balance. Okay, water in F. Di ba 70%? Kasi 30% yung kay salt eh. So 70% times 10,000 kilogram equals water in ml. Paano yan? Paano yung water in the mother liquor? Ayun, no? You do the same thing. Okay? Di ba nag-basis tayo ng 100 kilogram ng water? So, to get the percentage of water in the mother liquor, so 100, okay, divided by the sum of 100 over plus 21.5. So again, I repeat that, 100 divided by the sum of 121.5. Or you can simply subtract 17.7%, which is the percent of salt in the mother liquor. So subtract that 17.7% from 100%. So ilan yun? So 100% minus 0.177 times ml. Ganoon din ang gagawin natin sa crop, no? So sabi natin 37% yung Na2CO3. So how about the rest? Or how about the water? No? So si water, okay, di ba 180.2 yung ating molecular formula? Lagyan natin dito. Divided by the total, which is 286.2 times C. So I need to simplify further muna itong ating second equation. So that's, this one is, sabi natin 7,000 rather, equals 1 minus 0.177 it's 0.823, okay, times the ml, plus this one becomes 0.623 C. Okay. So there, we have our second equation. O di yun na yun. You have two unknowns, ML and C. You have two equations, 1 and 2. All you have to do now is to solve these two equations simultaneously. All right, so solving 1 and 2, and of course I won't show you how it's done. So assuming alam nyo na yung paano gawin yan using your calculators. So solving this equation simultaneously, you will get the following. So your motherly core will be 3,630 kilogram, and your crop will be 6,370 kilogram. And yun naman yung tanong sa problem. Ilan daw yung ating yield ng crop, which is therefore ang answer. So the yield of crop is this. So this is the final answer. And of course, if you're going to check, the total of ML and C should equal the amount of F, which is 10,000 kilogram. Now, for letter B, ang sabi dyan, 3%, okay, of the total weight of the solution is lost by evaporation. So paano yan? Siyempre, mag-iiba na yung ating material balance. 3% daw ng total weight nung solution ay nawala because of evaporation. So what will happen there? Well, I will leave that exercise for you.